In this video, I'm going to read through the guidelines for analyzing graphs of rational functions with you. Basically, you're going to have to answer some questions involving rational functions. You're going to have to be able to sketch graphs of rational functions. So it's important that we look over this and make sure that this all makes sense. So let's start off with a function f of x that's equal to sum n of x over d of x. So this is just your numerator and this is your denominator, and these are both polynomials. Your first thing that you want to be able to do is simplify f if possible. So any kind of factoring you can do with the numerator and the denominator, and then if any common factors cancel out, make sure you take care of those. Step 2, find and plot the y-intercept, if any. Remember that when you're finding the y-intercept, anytime you have a y-intercept, you have an x value that's 0. So we've dealt with y-intercepts all year. Same as before, set x equal to 0 and solve for y. If it's written in function notation, you want to evaluate the function at f of 0. Step 3, find the zeros of the numerator, if any, by solving the equation n of x equals 0. So in other words, take whatever's in the top part of your rational function, the numerator, set it equal to 0, plot the corresponding x-intercepts. Basically, what this is equivalent to is just setting y equal to 0 and solving for x. So if you're setting y equal to 0, that's the same thing as setting f of x equal to 0. Y and f of x mean the same thing. So if you're setting f of x equal to 0, so when does 0 equal a numerator divided by a denominator? Well, the only way that's going to happen is if this top part is 0, which is why we're saying just set n of x equal to 0. Step 4, find the zeros of the denominator, if any, by solving the equation d of x equals 0, then sketch the corresponding vertical asymptotes. So we talked about this previously with the vertical asymptotes. Just take your denominator and set it equal to 0 and solve. Step 5, find and sketch the horizontal asymptote, if any, by using the rule for finding the horizontal asymptote of a rational function. Remember that when you're dealing with horizontal asymptotes, you're essentially looking at the degree of the numerator and the degree of the denominator. Remember, there's 3 different cases. Case number 1, if your degree of the numerator is less than your degree of the denominator, you're going to want to have a horizontal asymptote at 0. If the degree of the numerator is larger than the degree of the denominator, then you do not have a horizontal asymptote. And if the degrees are the same, you take the ratio of the leading coefficients, and that will be your horizontal asymptote. And it's always going to be y equals some number. Step 6, plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. So basically, you just want to kind of figure out where your curve is, pick some x values, run them through the function, see where the y values land, and then plot those points. Number 7, just connect everything. Use smooth curves to complete the graph between and beyond the vertical asymptotes.